Hello, everyone, and welcome to the Air Devils meeting of Thursday, January 28th. Today, we'll be discussing the CAD design of our aircraft, particularly doing some final checkups before we actually start building the thing. From the last time some of you saw this, we've made a lot of changes to the aircraft and a lot of updates to the CAD. We are getting very close to completion, but the last 80% is 90% of the work, so they say. So, without further ado, let us open up the CAD and show off what some people have been doing. So here is our work so far. We have the aircraft mostly feature complete. There's still some things that need to be done, like actually placing servos inside the CAD model and getting the front landing gear in and placing in supports for these payload boxes in order to prevent them from shifting around during flight. And we also need to design some sort of floor and access mechanism to get these sensors or these payloads in and out of the fuselage for mission 2, the payload delivery mission. There's also a configuration manager, which I've spent a lot of time and had to redo multiple times. So now there is the various different payloads or the configurations for mission 2. Like, for example, if we were to, well, that's something I should probably fix. Like, for example, if we were to only fly with 4 payloads in mission 2, 6 payloads in mission 2, and of course, mission 3, the flight with a single payload. We do need to make some minor adjustments to this configuration in particular, in that there should be like a recess in this bulkhead right here in order to support our sensor design, or our sensor inside the fuselage while it is strung up, basically. We also need to include the retraction mechanism that's still in here, but other than that, there's a lot of good work in here that I am very proud to see a lot of our members contributing to this. Like Zach, who was working with Kevin to design our empennage for the aircraft, which you guys have done a really good job on. And Pranjul, who's working on the connection, or the fillet that basically connects the aft end of the bulkhead to the keel in an aerodynamic manner. So good work, guys, on that. Give yourselves a pat on the back. But yeah, what we were just discussing about earlier in the conversation is that there is a couple things that we need to update on the wing of the aircraft. Currently, we have the ailerons sized basically as a 8 by 2? 8
yeah,
inches?
they're 2 inches. I don't know how long to the center rib. I think it's, yeah, it's 14
they
inches,
are, yeah, 14 inches by 2, or yeah, 14 inches by 2, so 28 inches on each side. And we need to basically shorten the rib and or shorten the ailerons and make them longer in order to keep the same area, but also significantly ease our actual manufacturing, because little tiny bits of plywood are liable to snap and break and not do anyone any good as ailerons. Well, some planes might be able to fly without ailerons. This one might be a bit difficult. As Evan, how easy would you think this plane would be to fly without ailerons?
Me?
Yeah.
Probably without aileron.
You cut out there.
I don't think you'd be able to fly it without ailerons.
Yeah. So we'll make those a little, finalize the shape of that in the near future. And another thing that we were discussing is that with the Mission 6 payload configuration, which will be about 20 pounds of aircraft all up, we'll need to have our landing gear maybe forward of this bulkhead. That has to do with the rotation angle on takeoff. What is the command to rotate the camera in SolidWorks? Like I know I can do this, but I want to rotate around the x-axis.
I believe hold Alt and something.
No. All right, whatever. So basically, if you can imagine on this, there is an angle that exists here on takeoff that is dependent on the landing gear's location and the location of this kink in the tail. So if we move the landing gear up to say here, that angle is now shorter and that's less rotation than we can get on takeoff. So that's something I need to go ahead and figure out, because currently that's 13 degrees angle of attack on takeoff, which is probably enough. The plane will probably stall out much sooner than it gets 13 degrees AOA. But yeah, that's just something we need to take into account when designing this aircraft.
Would adding a sweep to the wing help for the rotation that you were talking about?
No.
No.
Adding sweep to the wing would move our center of pressure generated by the main wing structure farther aft, which would actually make it a lot harder to rotate the aircraft on takeoff, because the center of gravity would be farther away from the center of pressure. And it would, yeah, we would not, that's the opposite of, so stability is one of the most important things when designing an aircraft. But if you have the aircraft too stable, then you can't get the nose up on takeoff, which is something we want to avoid on this. We'd like the aircraft to be as close to balanced with some stability as possible. Less 747, more, I don't know, C-130. So, yeah.
Okay. Where exactly, like, or what's the difference between the center of pressure and center of gravity in this aircraft right now? Like, how far are they?
Kevin, you want to cover that?
Figuring. Oh, can you hear me or no?
Yeah, we can hear you.
Okay. So it's going to really depend on what mission we're flying and how we configure the plane, which is something that we still need to figure out once we get all our weights and everything double checked. But so for mission free, when we only have one sensor, that's going to put basically all our CG is going to be right where we can get that wherever we want it to be pretty easily. But for the second mission, when we're going to carry all these payloads, it's going to depend on if we can 3D print them and put a lot of mass in certain places. And that's one thing we're trying to figure out if we can do in our manufacturing.
Right. Okay. Thank you, Kevin.
I'm working on that right now. I have been hard at work 3D printing our actual sensors to, let me just get that in the tree. I want to open the subassembly. So this is the sensor payload that I have, I designed the aero shell, and then Natish, who is not here right now, designed the actual electronics of the sensor. I just change this to the actual exterior. So this is the CAD model that I've been working on. If I just open this part directly. And then here is the actual sensor as built. Let me just turn off my virtual background in order so it doesn't get cut out. So here is the sensor as 3D printed. It has threads inbuilt and aeroshell basically, but it might be heavier than expected. So I need to get a scale actually to weigh it and figure out how heavy it actually is so we can then adjust how heavy everything else needs to be.
I have a scale at my house, but I don't know if how soon you need that to be weighed.
Yeah, I'll probably just go to the store tomorrow and buy one.
Yeah,
I need
Harbor
a
Freight
scale
also
anyways.
has. That's where I got mine from. If there's a Harbor Freight around there.
I got a second one of the big air double scales at my house, so I can drop that off. I can even do it today if you wanted.
Nah, I'm going to the store tomorrow anyways. I'll pick up just a kitchen scale there. Should be able to weigh this. There was a weight estimation in the SolidWorks or the when I actually printed it out, there was a weight estimation of about 600 grams or so. I don't know.
Dang.
So this might be actually kind of heavy, and I might need to print this again, but with some different settings to hopefully add lightness. Because there's a lot of things you can do when actually printing this versus how it's designed to adjust how it actually how heavy it ends up being. So I'll play around with that. I had a question in the chat earlier about how long this took to print. This took 17 hours basically of my printer running in the background. I don't know if you guys can hear it in my background, but I am running the printer right now to go ahead and make the other components of this subassembly, such as the this back insert here, which acts to basically create drag on the aft end of the sensor. Try and get basically we want the center of pressure to be as far back as possible in order to make this thing as draggy as possible.
Did you make sure the threading tolerance isn't too tight?
We'll find out. Luckily, this base insert is a lot quicker to print. It's only about 3 hours, and so I can just print another one of these with slightly different sizing and threads to try and get one that fits versus
Sweet.
this one that takes a long time. In fact, we might even try and test fly this this weekend, if possible.
Yeah, we need to bring the plane. Oh,
Yeah.
you still.
So
Evan has it, right?
Yeah, and we can basically tow this underneath our last year's aircraft and determine if it is how stable it is, basically, without any mass in it. So yeah, that'll be something that we will figure out probably tomorrow in the leadership meeting. We'll let you guys know when and where we're gonna be if we do plan on test flying this weekend. So going back to the main CAD model, yeah, landing gear placement needs to be finalized. We also need to design and implement into the model how the aft end of the torque box will be held on to the aircraft, basically. Because the current plan is to have if I just change the transparency of these guys. So there are channels in here that connect to this front bulkhead that then go into the torque box, and there will be dowels that connect to the two to prevent the wing from twisting off the fuselage that way, but we still need something to prevent this back end from sliding backwards or lifting off too much and actually snapping this whole bulkhead, because both of those would not be good. The wing is probably the one part of this aircraft that needs to be staying on all the time. We can lose bits and pieces here and there, and it wouldn't be pretty, but if we lose the wing, all hope is lost. So there's some really good design elements in here that I'd like to highlight that Ivan helped put together. So there's this side plate that is forming the main part of the fuselage. And what's really cool about this side plate is that it also acts as a locating feature for all of these bulkheads that go throughout the body of the aircraft. Unlike a lot of competitions, we actually have to end up building this thing. Still working on that. And so by having this side plate referenced to these bulkheads, the side plate acts to locate the bulkheads onto this bar. So by simply putting on the putting together this piece, the snapping together the bulkheads with the side plate, everything is already pre-located, and we don't really have to guess where things need to be. You can't always get away from that. Like for example, this piece, we're gonna have to carefully measure the distance between these two before we glue on the bulkhead to the keel piece right here. And same deal with these pieces which hold in the battery. But as much as we can get away with it as possible, I'd like pieces to be have some locating feature on them. And as part of that, Jack here went ahead and where did you put the jig for the sensor
the
retrieval?
jig? Okay.
Yeah,
Then that is going to be under the wing.
gotcha.
Jig is right underneath the full wing.
Okay. Yeah, do you have the assembly with the wing in it? Okay,
Yeah,
you do.
yeah. That's
So-
just the mock wing, though.
Yeah. So this is an example of making manufacturing tooling that we can actually use to build the aircraft. So this piece, this is the torque box that is all made of a couple pieces of balsa wood that have been glued together. But then we have to align ribs onto the torque box and actually to make the wing. And the placement of these ribs is fairly important. We want them to be as vertical as possible, aligned with the torque box, as well as properly spaced, because if they're too close together, we end up losing some of the strength of the wing. And also, it makes a lot of things harder, especially if, say, for example, this rib right here is misplaced. That is where the motor actually attaches to the wing. And if the motors are asymmetrical, then that makes problems for our dear test pilot, Evan. So we want them to be as precisely aligned as possible. And so having a piece like this that we can laser cut to the machine's precision instead of using the old Mark I eyeball to guess where we put each piece helps a lot. Quite a bit. What is hide me?
Yeah, that looks really good.
There's two things called hide me. If you hide them, then it just shows just the crane, not the wing. So.
Gotcha. Yeah, and so this will be something that we can laser cut out of some wood, and will make building the wing a lot easier. Because in the actual aerospace industry, building it is probably like 60 to 70% of the battle versus designing it. So yeah, good to have design sense in our actual CAD model. All right, so does anyone have any questions?
If you want to try to put in the my sensor retrieval mechanism, just I haven't changed it very much, but you can import it in.
Okay. Sorry, my headset's beeping at me. I need to plug it in. Of course, it'll take me to the 8th try to actually figure out the right side of the USB. Here we go. All right, let's try and insert.
Mine uses the new USB cable that is
USB-C.
directional. Yeah.
Sensor retrieval. Slide SAM. I need to fix that sometime. All right, where is this supposed to fit? I should probably make it mission 3.
It's pretty much in the right next to the batteries.
Okay.
In between them and the one sensor.
I have a message in the chat. Can someone read that to me?
I am a freshman. I don't really understand anything, but I find this stuff so interesting. Hope to learn a lot from you guys. Sure will.
Yeah, you will. I was once a plucky freshman who didn't know Jack. I didn't know Jack as a freshman, but now I know Jack.
Your puns are great.
uh,
In fact, now you know multiple Jacks.
yep, now I know multiple Jacks. All right. How do I push this forward?
Yeah, and it's
Minor.
also never too late to get involved too, because there's still lots of CAD stuff that needs to get done on this. So if you want to learn, just let any of us know, and we can help you out, and you can help design parts of it.
Yep.
Too.
Like I said earlier, we had a new member help build this empennage assembly in order to get that all set up. But we still need, of course, like I said earlier, pieces designed in here to hold the payloads in position inside the fuselage. Probably like a floor plate, a removable floor plate installed here for the mission, for the ground mission to actually load the sensors into the fuselage. That also needs to prevent these payloads from falling out in flight, because that would not look very good if our payloads fell out of the airplane. Yeah.
Oh, can you show me exactly where the Bombay door is going?
Yeah.
Is it just the?
So the Daniela, have you figured out the integration yet of that? Is she not here? She was here earlier.
Well, is it just between the first bulkhead and the second one?
Yeah, it's between these two bulkheads. There's going to
Okay.
be some servos that are down here that actuate the doors.
Oh,
If I have, there
all right.
was.
I'll have to make sure I don't put my sensor mechanism in a way that will block that.
It'll look something like this, basically, with servos back here.
Yeah.
So the doors open up. So most of the intruding parts are in here. But we might have to, considering how tight of the fit. No, don't do that yet. Okay, we still have some room that I can move these payloads back farther. And basically, we'll have room for those servo arms to fit in front of the payloads inside this bomb area. But that will be a integration fun time. So yeah, SolidWorks is thankfully fairly pretty easy to learn. I learned it mostly through the club and not through the CAD class. And thankfully, it's a lot easier to learn than CATIA, which is a whole nother ball game right there. So yeah. Overall, this is looking really good so far. We just need to get the last features in, and as long as the payloads fit inside the bomb bay, that's the thing that or the payloads fit inside the plane. That's the main thing that I've been worried about this past week. So it's looking pretty good so far, but you just have to watch for the space in here to actually fit the moving bits.
Hey, Daniel, it's T here.
Hey, T.
The advisor. Okay, I like the way the loft came together. The only thing is, do you have any more confidence at this point that we are good to go with center of gravity? And if not, what's the fallback position if we got to stretch the nose and move the batteries further forward?
So each of these boxes is about a pound. And we can, because the payloads, the sensors just need to be the same outer dimensions and the same mass as the payload, as the sensor inside the box. So we can weight the front of the box versus the back, and therefore we have a lot of freedom to say, for example, our center of gravity is, dare I say, too far forward. We can flip these payloads upside down, just flip them around, and now we have more mass aft and vice
Okay.
versa. So as long as one side is weighted versus the other, it should make things easy to balance it out. And we already have a pretty hefty amount of nose on the aircraft, especially if we leave this back section hollow. We could fit 8 payloads in this aircraft, but with 6 front heavy like this, we should be fairly good to cancel out the mass of these two, affecting the rear, or to counteract that. All right. Daniela, how's your progress on getting the bomb bay assembly into the actual CAD model?
It's going good. I was working on that earlier. The only issue I have was from prototype 2 to prototype 3. I think the dimensions slightly changed, so I need to just readjust mine a little bit.
Okay.
But basically, I think I'm just going to throw on like the door with the frame so I can have the hinges in an appropriate location. And then I might need a little more space for the servos to go in.
Yeah, I was just talking about that. We can move these boxes about that far, and that gives you
Okay.
a little bit more space.
Okay.
But moving other things around, like moving this bulkhead back, would be challenging, and moving this forward would also be challenging. So if you can try and make it fit.
All the way up there. Okay. I see.
Yeah, in this area.
Yeah, I was looking at that like rib right there, the main rib, I think. I was thinking of just filling that out and mounting the servos on top of that. But if you want me to push it farther back, I can.
You mean this bulkhead?
Yes. Yeah.
Yeah.
Just make it solid, like it's in your.
Yeah, just fill it out and then mount them on there.
Yeah, that'll work.
Because I was just in the Tooker eSpace and I was able to get the prototype going. So the large servo arms that Evan gave to me, they were able to open the doors 100 degrees.
Okay.
So right now I just need to figure out exactly how to put those on so we know the right angle to open them at.
Gotcha. All right. That all sounds good. Jack, if we do end up, let me just move this component back. So if we do end up putting this spinny thing back here, right, for mission 2, we might run into issues. Like, do you rely on the exact geometry of this angle here to clamp in your mechanism, or do you think you can make it work so it clamps onto the inside keel bit here?
So
with a
the
square
idea-
versus a angled thing.
The idea is, and I only have it on one side, is that the wheel can be removed from the clamp mechanism, so the clamp can stay up front, while the back that just gets thrown back, like the barrel and the heavy motor. As far as the angle, that angle thing is actually really helpful, because that way any tolerance issues we have, we can just slide it a bit forward, and then that will tighten up the space between the motor end and the bearing end. So,
Okay. I mean,
Hey, Daniel.
Yeah.
You think we could make some of the 3D printed pieces to mount the wing in the front, in the back too, and then move the wing mounts further back?
Move the wing mount further back. What do you mean?
So you see, I don't know who put those 3D printed pieces in the front of the wing mount.
Yeah, that was Max.
We could do that for the back too. And
Have like a bolt or something that like the same sort of deal how we have pegs here, we have a bolt on this end.
yeah,
I mean, that could work. It's just that that means we'd have to have some sort of access to this back end to like screw and unscrew that bolt.
oh no, but it would be vertical.
Oh,
Like,
like a vertical
the same
clamp,
thing.
like how we have the. Do I have it on this computer? No, I have it on my other computer. Like
Yeah,
how
I
we
think
have the
just
clamp
like,
on the keel of last year's aircraft, instead have the clamp on this back end.
yeah, 3D print so it like an extender piece off the back like we have on the front so it matches that angle.
Okay.
And then on that 3D printed part have 2 holes in it that the bolts could go through.
Yeah, that'd work.
We just have to make sure that 3D printed part is glued really well to the keel.
Yeah, it'd have to be. Yeah, that piece would have to attach, preferably mechanically, to the keel, because it'd be in tension and compression versus shear. It mostly tension. So I don't want it. Basically, I don't want the plastic bit to peel vertically off of the keel. So if we could make it fit into, like, maybe hook on to this bulkhead right here,
Yeah.
that would work. But yeah. So if anyone is interested in tackling that design challenge of fixing the wing back plate, or basically fixing the wing on the back end to the fuselage, that is a CAD challenge in the making, as well as a mechanical design challenge that is a great example to talk about on interviews. I sure as hell talked about some of the stuff that I designed in my interviews when I was talking to Lockheed and other companies. So great chance to get a story to tell. So yeah, if you're interested, send a message in the structures chat of our Slack channel. Structures, and yeah. Oh, here's sensor payload right here. Oh, you guys were in the eSpace when I was starting my meeting. Gotcha.
Yeah,
right.
sorry.
No worries. All right, so that is everything I have planned to talk about for this meeting. Any questions, comments, and concerns?
Yeah, actually, I have a couple of questions. They're not like mechanical questions, but so I noticed that you stated like the missions, and are those like goals that you want to achieve with this built aircraft? And also, what exactly are payloads?
So, yeah, some of you might not be totally up to date on what our club is. So, we compete in the AIAA Design Build Fly competition, and so we have a set of rules or challenges that we build our plane to. And this is this year's. It's 20 pages of a bunch of nonsense for the most part. But we have 3 missions that we have to complete in order to score, and 3 of those missions, or actually 4 missions, 3 flight missions and a ground mission. But 2 of those missions have performance metrics under which we are compared against the other teams. So for mission 2, it is the delivery flight, and the delivery flight is we have to carry a bunch of sensors in boxes.
Is that the thing that you 3D printed?
So, yeah. So the sensor in the box is this guy right here, which, let me just adjust the transparency of this so it shows everything.
Yeah, I see it.
Yeah, the sensor's in a box that has to be able to survive a drop from a certain distance. So that is in progress. But
awesome.
Then we have boxes that are just empty. They have weight and same external dimensions and same mass as the sensor in the box. And it's to simulate carrying a bunch of sensors to a destination.
Okay.
So we have a bunch of those. And then mission 3 is where we actually have the sensor. If you look at my camera right now, I'll go ahead and pin
Yeah, I
that.
see you.
Pin. So we have the sensor like this dangling from the aircraft behind it, and then we have to retract it back in as well as deploy it. Just went backwards there.
Oh, okay, I see.
So mission 2 is just carrying them around. Mission 3 is deploying this thing. So yeah.
That's cool. That's cool.
Yeah.
How do you guys like show proof of that? Do you guys like record videos when you guys do it?
We don't know
Or-
yet.
Oh.
We just got word last week or the week before that the competition in-person part is canceled, and so it'll be virtual. So we might have to submit video of our plane. But
Sure.
otherwise, usually it's in person in either Tucson or Wichita, Kansas, and we
Oh.
would compete against 50 odd other schools. So
Wow. Okay, that's cool. Are we gonna like meet up like once we actually get the aircraft built
yeah,
and you know
we're
all
gonna have test flights. For the build, most of it is going to be virtual, as virtual
Okay.
as a build can be. And the leadership team is going to be meeting up in person to actually build it, just for COVID concerns. We can't really have a bunch of people working in close proximity.
Understandable.
Yeah. So, but we're going to have test flights of a chance to get to see your work in person as we get closer to the competition. The competition itself has a deadline of April 18th, I think, is the day of days. It's in here somewhere. But April 18th, or that weekend of that week in April, is when the competition is supposed to be, and that's when we're supposed to submit our videos. But in terms of deadlines, in 2 weeks, there is a 60-page report due that I'm going to have to talk with the leadership team about tomorrow. And luckily, you guys don't really have to participate in that if you don't want to.
No, I'll try my best and help.
Yeah. So that's how long is the aircraft from completion? CAD wise, again, we're probably about 80 to 90% there. The big pieces are in, but we just need the little pieces. And in terms of actually completing the aircraft, once we have the CAD finalized, even before we have all the little bits and pieces in, but we should have all the little bits and pieces in, we'll actually start building, and that shouldn't be that long once we have all our materials in. But ASU as an institution is bureaucratic in nature, which means things can travel slowly sometimes.
Yeah.
We've ordered. Did we get that carbon fiber order in, Max?
Yeah, it was requested. Is yet
Okay.
to be approved. And
Gotcha.
you can start to see the bureaucracy, and it piles on from there.
Yeah, so we got like $500 worth of carbon fiber ordered. A bunch of. Did we order more balsa wood?
Not yet.
All right,
Yeah,
and
we're
we
gonna
also
need,
have. Or go ahead.
yeah, we're gonna need a lot of. I'll put in the chat, leadership chat, for what type of balsa we're gonna need for the updated ribs and jig.
Gotcha. And we've ordered a few $100s worth of batteries, or well, we are going to order. We're still talking about that. Bunch of sensors and a bunch of other stuff that needs to be then shipped once it's approved. And yeah, so hopefully everything gets here on time, but a lot of that's out of my control. So I try not to worry about it. All right. So that's everything. All right. Catch you guys next week.
Awesome. Thank you